that trajectory along the way. Imagine if you could shoot an arrow stop it in its path, check to make sure if it's on course for the target, and if not, be able to nudge it back to its target so that it's headed for the right place. Now, of course, our spacecraft is moving at about 60,000 miles per hour. It never stops. So the corrections have to be performed along the way while the spacecraft is still in motion.
We track the spacecraft using the Deep Space Network of antennas, and we figure out exactly where the spacecraft is, where it's heading, and then compute where it actually needs to be. We develop commands to fire the thrusters on board the spacecraft to make any corrections that we need to make.
For approximately 5 minutes.
22 hours prior to entry, we have one last chance to make a fine-tuning of where we're going to land.
The arrow hitting a target is a decent analogy for what the navigation team does.
But in reality, it's a lot more complicated than that.
Earth and Mars are rotating around the Sun at various speeds in constant motion.
The spacecraft itself is moving very fast across the solar system. It's trying to hit a moving target, and that target is also spinning on its axis. And we have to keep all of these things in mind while we're attempting to hit this target. It's pretty challenging, all these things that you have to take into account and actually get done during this so-called cruise phase, where it's not laid back at all by any means.